All right, 7th graders, we are taking a break from graphing right now, and we're just going to solve some radical equations. So solving radical equations, that's the first thing we're going to do. So what else are we going to do? Well, if I can find it here, where is it at? Here we go. Solving radical equations. We're going to identify extraneous solutions, and we're going to solve real-life problems involving radical equations. So you first might be asking yourself, Mr. Humphreys, what is a radical equation? Well, I know you were going to ask me that. So here's what it is. A radical equation is an equation that contains a radical expression with a variable in the radicand. To solve a radical equation involving a square root, first use properties of equality to do what? To isolate the radical on one side of the equation. Then use the following properties to eliminate the radical and solve for the variable. So notice that one key thing. You must isolate the radical. So here's remember, you can do whatever you want to anything to either side of the equation. So if you had an equation where you had a equals b, you can square both sides. They're equal. So if two expressions are equal, then their squares are also equal. So let's start with example number 1. Solve each equation. You must isolate the radicals. So here we're going to subtract 5 by the subtraction property of equality. You're going to get root x equals 8. Now, to get rid of the square root, you square it. That gives us x equals what? 64. Now, you may ask yourself, wait a minute. The square and square root, remember they cancel each other out. Because if you square this, the square root of x times the square root of x is the square root of x squared, which is x. All right, over here, we're going to subtract 3. So negative root x equals negative 3. Divide by a negative, root x equals 3. Square both sides, x equals 9. Seems pretty easy. And that's because it is. But there's a big difference here. There's a big thing that you need to be careful of. You must check your answers. You don't need to write it out. You can do it in your head. But for example, you take the 64, plug it in. Take the square root of 64, which is 8, plus 5, that does give you 13. You must check them. Both of these do work, so these answers are your final answer. Let's do another one. 4 multiplied by the square root of x plus 2 plus 3 equals 19. Step 1, we subtract the 3. 4 root x plus 2, these are easy, equals 16. Divide by 4 because of the division property of equality. That gives me equals 4. And then I square both sides. That gives me x plus 2 equals 16. That would give me x equals 14 as my answer. So once again, what do I have to do? You must check it. If I check it, it does work. X equals 14 is my answer. So what happens when you have a root on both sides? You get one root on the left, one root on the right, and you just square both sides. So I'm going to square this and square this. That gives me 2x minus 1 equals x plus 4. Piece of cake, I subtract the x, I add the 1, you get x equals 5. And I bet you can't guess what we have to do. We have to check it, and it will work. Now there's another option. This is something that is true with anything. And a lot of students, this is something where a lot of students aren't taught this. And this is something that you can do. I can take both sides of this equation, and I could graph two separate equations, which would be this. I could take y equals the root of x plus 4 and y equals the root of the 2x minus 1. Ladies and gentlemen, this is just like a system of equations. And here, they're equal, so you'd set them equal to each other to solve them. That's what this is. This is like solving a system by substitution. But notice the point of intersection. The point of intersection is 5, 3. But wait a minute, I don't want you to find the point of intersection. I just want you to find x. Well, x is 5, so that's another way you can do it. So how do you involve or solve a cube root within a radical equation? Well, I know this is kind of hard to believe, but I bet you that to get rid of a cube root, you're going to cube both sides. And that's exactly what you're going to do. So that gives me the cubed root. That does not give me the cubed root. Let me erase my mistake. That gives you 5x minus 2 equals 12 to the third power, which is 1728. I solve your equation, add 2, divide by 5, 346. I will check my answer, and I'm telling you it will work. So, extraneous solutions. You may ask yourself, what exactly is that? Squaring each side can sometimes introduce an extraneous solution. Basically, that just means it's a solution that does not work. So off to the side, write this down. The square root of x equals negative 2. Think about this. Does the square root of anything going to give you negative 2? Well, no. But if you square both sides, this gives you x equals 4. So it's telling you 4 is the answer. However, the square root of 4 is not negative 2. Therefore, this does not work, which means it's called an extraneous solution. So if I had x equals the square root of x plus 6, I've isolated the radical, so I square both sides. That gives me x squared equals x plus 6. And now we use factoring, quadratic formula, completing the square. You can use whatever you would like. So I'm going to try to factor this by getting everything equal to 0. Now, quadratic formula is just as easy. And it works for everything. So let's see, x minus x plus, that would be 3 and 2. That gives me 3 and negative 2. I would take both of these answers and plug them in. And if I did 3, let's see, if I plugged in 3 to my original equation, well, the root of 3 plus 6, that'd be 9. Square root of 9 is 3. So, yep, so 3 works. If I plug in negative 2 equals the square root of negative 2 plus 6. So that does not work. They're not equal. So negative 2 does not work. 3 is my only answer. Let's try another one. I want to isolate the radical. The square root of 5n equals negative 10. I now square both sides. You don't put a negative or put the negative 10 in parentheses, it will be wrong. 5n equals 100. That means n equals 20. Seems pretty easy, huh? And it is. Let's check it. Will it work? No, definitely won't work. And it gives it away right at the beginning. The square root of anything can't give us a negative 10 or a negative anything. So you automatically know this will not work. So this is no solution. So solving a real-life problem. The period p in seconds of a pendulum is given by the function p equals 2 pi multiplied by the root of L divided by 32. Now, side note, the period, you're like, the period P, what does that mean? I don't get it. Well, here's a little study tip for you, a little side note. Let's put that, I'll put it down here. The period of a pendulum is the amount of time it takes for the pendulum to swing back and forth. Well, now you know. L is the length of the pendulum in feet. A pendulum has a period of 4 seconds. Is this pendulum twice as long as the pendulum with a period of 2 seconds? Well, let's think. I have two equations. P equals 2 pi multiplied by L divided by 32. And P equals 2 pi multiplied by L divided by 32. In the first one, I have a period of 4 seconds. So 4 equals 2 pi. Multiply by root L divided by 32. And then we plug in 2 for the other one. And now we solve them. So I would first divide both sides by 2 pi. That gives me 2 divided by pi equals root L divided by 32. I square both sides. That gives me 4 divided by pi squared equals L divided by 32. I now multiply both sides by 32. That gives me L equals, let's see, 32 times 4 will be 128, divided by pi squared. Well, I need to give me an actual length. That gives me approximately 12.97. And what is the, let's see, the label is feet. Now, I'm just going to tell you, let's move this. Nope, I guess I can't move that. Never mind. If you ended up solving the other one the same way, I'll save you time. You're going to get L is approximately 3.24 feet. So is it twice as long? Well, no, it's not. 12 and 97 hundredths divided by 3.24. It's about 4 times longer than the length of the pendulum. So it's 4 times longer. Therefore, the answer would be no. Now, to explain your reasoning, this is it. You would say no because it's 4 times longer, not 2.